Okay, hello. Good to see you all. I'm going to kind of just jump in here. I'm a little bit nervous doing this on video or, however we're saying that. But let's start with this section here of 6.1. And like I say, I want to just kind of jump in here and get warmed up and get going amidst the turmoil here. So here in our first section, we're talking about radical expressions. And what are they? And radicals are, with the square root we'll start off with. All right, we're used to doing square root problems, so we have square numbers that make it quite easy. So if we had a bunch of square numbers, I could start off with something like square root of 64. That is common, and we kind of know that that answer is 8. Okay, if I have a radical with negative 64, then this is DNE, which means does not exist. Because if you look at the first one up here, positive square root of 64, it's saying what are two of the same numbers that when you multiply them together equals 64. And of course that is 8 times 8, which equals 64. Okay, I could rewrite 64 at the same time by saying what is 8 squared? Okay, and 8 squared is, it's one of the two 8s that we write this out. Because I know that 8 squared means 8 times 8. And then if I said, what's the square root of 8 times 8, which is the same as 8 squared, which is the same as 64, it's all the same, then my answer would be one of these 8s. So let me get rid of this here real quick. So the square root of 8 times 8 equals 8. And when we get into these more complicated problems, I'm going to show you the way how to do these manually without your calculator. Okay? And you'll be able to use your calculator on numbers. But remember, you have to put your answer in the form that they want, and it probably will not be decimal numbers. Kind of deter you from using your calculator. Okay, so this is what we're dealing with so far with the square root of some of these numbers. And what are some other numbers that are perfect square roots? So I could come down here and I'll stake it here. Square root of 36. Is 6. Square root of 100 is 10. And then if I had the square root of negative 81, now my answer changes, and that is going to be a DNE. Does not exist because it's a square root. Okay, got that part. And talked about this one already. So that's when we're dealing with square roots. Another example of what we're going to be dealing with here is this setup here of a radical. This is a radical. The number inside, underneath the radical sign, is called the radicand. Radicand. Okay, and then we also need to know there is really a number, and it's called the index number that goes here when it's something other than the square root. And the square root means what number are we talking about as far as the index number. And there's really a 2 here. They're saying what is the square root, or what is the second root of a number. And it's not written for the square roots because we use it more often than any other roots. So I could change this, and I could change this to maybe a 3 or a 4 or a 5. And then this is saying, what is the third root of whatever number is in there? Okay, and there's some perfect cube numbers, perfect square root numbers, of course, perfect fourth roots, fifth roots, sixth roots, etc. And I'm going to show you how to do that when we get to them in our examples. Okay, so this is kind of like what we're talking about here thus far. And let me see if I can get to some examples that we can further this along. Okay, hold on one second. All right. I might as well bring my book with me. Ta-da! All right, so let's write these up here. So I've got cube root. What is that? The fifth root of negative 32. And the fourth root Okay, so here are some examples here from our from example 2. Sorry, I'm moving around and all that kind of thing, but I'm in my basement with my whiteboard doing this so we can get through the semester, don't forget. I'd rather be in class, believe me. Okay, so here are some examples of different roots. So this one here, we're talking about the cube root of negative 8. Now, if it is an odd root, think about this. If this is an odd root, I can have a negative underneath the radical sign. So that means 3 numbers. If they're all negative, here's 3 numbers. If they're all negative, my result would equal a negative, right? A negative number, a negative number, a negative number, and it's going to equal a negative number. If I have a so I'll leave it at that. They have to all be negative for me to get negative 8. So if I'm looking at this, I want to know what is the cube root of negative 8. So I want to take the 8 and I want to do my breakdown, my tree branches, which is really a lot of fun. I mean, I think so. It's easy as you break the problem down, then you can deal with the numbers that are left over from the prime factorization. So if I can take this 8, if I do the prime factorization, I end up with 2 times 2 times 2. Okay, I know this is 4 times, we've done this enough to, 8, I know, well, how many times it breaks down, what the prime factorization of it is. So here's what I've got. I've got 8, which is 2 times 2 times 2, and I know they're all negative. And because it's the cube root, my result has to be a negative 8. So when I multiply this across, I get negative 8. So the cube root then, what can I say? I can look at this as, in this little space here, I'm going to write negative 2 times negative 2 times negative 2. For every 3 of the same number, put my index number here, which is easy to forget to do. So this is saying what's the cube root of negative 2 times negative 2 times negative 2? So the way I do it, the way I present it to you to learn, if you don't know, is I'm looking at this, I'm saying for every 3 of the same number, I'm going to take one of them out. So I've got 3 negative 2's, I'm going to take one of them out, negative 2. So what's left under the radical after I take the 1 out of the 3 is nothing is left. So my answer is just going to be this negative 2. So the cube root of negative 8 is negative 2. Because negative 2 times negative 2 times negative 2 is negative 8. Okay? How about the square root of negative 4? So that means what are 2 of the same numbers that equal negative 4? Well, duh. If I break this down, 4, and if it's negative 4, then I've got, what's the problem here? If this is negative, I'm going to have 1 positive number, 1 negative number. That equals negative 4. So that's like negative 2 times 2. Well, they have to be the same sign. They have to be the same number, exact same number. So here, if I put this under the radical sign, now I'm saying what's the square root? This does not exist. This is one of those problems there. It doesn't exist. What kind of an index number is here? It's a 2, which is an even number. So even number radicals with a negative underneath does not exist. Okay, it does not exist because same rule. I'm going to have a positive and negative number. The numbers have to be the same. When I have an odd number for a radical, for an index number, then it's possible I could have a answer. Okay, depending on what the number is. Okay, so let's go on to, this is a negative on the outside of the radical sign. So this is easy. I'm just going to attach the negative to the result of the square root of 25. So what's the square root of 25 is 5, and then that negative just comes along with it, so my result is negative 5. That's how I get a negative result from something like a negative on the outside of the radical, and then whatever the square root is on the inside. Okay, here I've got negative 32 with a fifth root. Now I'm going to break this 32 down. So I got 32, and I'm going to break it down to be, let's see, what is 32? 8 times 4. I'm just thinking of two numbers that I know equal 32. 8 times 4 does. The 8 I'm going to break down. I know it's 2 times 2 times 2. And the 4 I can break down, and that's 2 times 2. So these can all be negatives. If they're all negative numbers, will I have a negative result? Why, sure, because I have an odd number. So this part here, this is negative 2 times negative 2, which is 4. This negative 2 times negative 2, which is 4. And this is one more negative 2. So what's 4 times negative 2? Negative 32. So therefore, I can look at the cube root, not the cube root, the fifth root of negative 2. I'm going to clear this up a little bit so you can see. I'm just rewriting it in a different form, this negative 32. I broke it down. I'm putting this whole thing under the radical. And then I've got the fifth root here. And now, what am I saying to myself? I'm saying for every 5 of the same number, I'm going to take one of them out. 1, 2, 3, 4, 5. That's all there is. For every 5, I'm taking one of these negative 2's out. So the fifth root of negative 32, which this equals, is negative 2. Okay, and how about this one? Now this is an index number of 4, which is an even number. I have a negative under the radical sign. So what's my answer for that? I can't have an even number of numbers that will equal 81 with the result being negative. So this one is a DNE. DNE. And that's my answer for that fellow there. Okay, we have a different variety of problems, and I'm going to show you how to break it down similar to this one, and then take your index number of the same numbers out, and whatever's left stays underneath the radical, and whatever comes out, comes out. So it's just, total math, just like getting into it and having fun. Knowing your times table, of course, is always number one. I keep saying that too, I think. All right, so let me erase this real quick. I don't know how I'm going to do this with the letting the tape run as opposed to turning it on and turning it off. So I'm having a little bit of a learning curve myself with putting videos out with me in it to show you have the same teacher teaching the same way. Nothing new. We look at the problem we had with the sub. A little bit of a problem anyway. All right, let's see what our next example is. That was it, example 3. Variables under a radical. Dealing with the variables. So now, let's see, I have 3 examples. So I've got the square root of 25, and that is 8 to the 4th, b to the 6th. I'm going to maybe shut this off while I write it up. Oh, no, I'm not. What a pain. Maybe I'll do some editing. Yikes. All right, how about this one? The cube root of x to the 6th, y to the 12th. And this last one is the 4th root. Fourth root, 81 r to the 8th s to the 20. Okay, so here is example 3. And let's do this. So this is the square root of 25, a to the 4th, b to the 6th. All right, so this is the square root of 25, which I don't think we'll have too much of a trouble with. But I'll demonstrate what I'm going to do for some of these other problems with this one. All right, so show you how it works. And you won't have to do this for the square roots, I hope. But I'm looking at this as what? Let me take down my 25. 25, a to the 4th, b to the 6th. So this is almost ridiculous for what I'm going to do, but I'm going to do the prime factorization of this. So 25 I know is 5 times 5. A to the 4th I know is a times a times a times a. There's 4 of them. And b to the 6th would be b times b times b times b times b times b. And there's 6 of them. So I'm looking at this as saying the square root of 25, a to the 4th, b to the 6th. And now watch, this is the fun part. For every 2, remember the square root, what is the index number? It's a 2 here. Not written for square roots. I'll probably say that like 100 times. All right, so that's saying for every 2 of the same number, I'm going to take 1 out. And let's do that. So I got 2 5s here, so one of them comes out. I've got 2 A's, so an A comes out. And I got 2 more A's here, and so I'll square that. It's A times A. I've got 2 B's here. That's B. 1 comes out. For every 2 of the same number, 1 comes out. Well, here's 2 more B's, so another one comes out. That'll square it. And here's 2 more B's, so that's going to make it B to the 3rd. And this is my answer then. Okay, this is how that works when you're taking the cube root, the 4th root, the 5th root, and now even the square root. There's our example of that. Okay, pretty slick. All right, I like it, I like it. All right, so I'm going to erase this now, and I want to give me some room for these other guys. All right, I can leave that. Okay, so let's see. Now, here I've got the cube root of x to the 6, y to the 12. Oh, boy, I really don't like that. So the cube root. So I'm going to prime factorization of this. So I got 6 x's. 1, 2, 3, 4, 5, 6. And then I've got 12 y's. Yuck. Y times y times y times y times y times y times y. How many is that? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And these are all multiplied together. I might as well, just to be clear with all of you. All right, so now I'm looking at this as saying, what is the cube root of all this? X to the 6, y to the 12. All right, so I'm going to what? I'm going to take 3 of the same numbers, or variables in this case, and I'm going to take out 1 of them for every 3. So here I've got 3 x's, so 1 of the x's comes out. Here's 3 more x's, so I'm going to take out another one. I'm just going to square it, and the x's are done. For every 3 y's, I'm going to take 1 out. Here's a y. Here's 3 more. I'll square this. Here's yet 3 more, so that makes this a 3rd, or a 3, y to the 3. And here's 3 more y's. I'm going to take yet another y out, and that makes it y to the 4th. If you happen to notice that if I take my index number, divide it into the 6 for the x's, I get 3 goes into 6 2 times, and I get x squared. 3 goes into 12 4 times, so that's where I get my y to the 4th. Kind of shorten things up for yourself, but I'm talking to you like your head is empty, like you don't know what's going on at all, and I'm just going to do it that way. the rest of you I know will grasp this and move on. Okay? All right, so here is the last one. This is the fourth root now. So I've got, look at this, s to the 20. Do I want to write s 20 times? Not really. All right, so I'm going to break this down. This is going to be 81. I'll do it here. I don't know where I'm going to do it. Let's try it here. 81 breaks down to be, what do you think? That's 9 times 9. And then the 9s break down to be 3 times 3 times 3 times 3. Okay, so I'll do it here. 3 times 3 times 3 times 3. That's the 81. R to the 8th means R times 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 R. 1, 2, 3, 4, 5, 6, 7, 8. 8 R's. 20 S's. Well, I got to do it. So I got a S, 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 S. There's 5. S, 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 S. 5. S, 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 S. 5. And S, 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 S. 5 more. So I'm looking at this now to say, what is the fourth root of this? Fourth root of this, all expanded. All right, so for every 4 of the same numbers, I'm going to take one of them out. Okay. 1, 2, 3. Here's 4, 3. So one of the 3 comes out. There it is. I've got 1, 2, 3, 4 R's. So 1 comes out. 4 R's. Like this. Oh, I missed one. 1, 2, 3, 4. And then I've got to use this one. And here's 1, 2, 3, 4. So there's another 4, so I'm just going to square that R. Okay, now I've got all these S's. For every 4, the index number tells me that, of the same number, I'm going to take one out. 1, 2, 3, 4. 1 comes out. Here's an S. 1, 2, 3, 4. Here's 4. An S comes out, so I'm going to square that. 1, 2, 3, 4. Here's an S. That comes out. I'm going to cube that now. And what I got? 1, 2, 3, 4 right here. So this now is going to be S to the 4th. Use my rag here. 4 up to here. And then I've got 1, 2, 3, 4. And that gives me one more set of S's, which would make it S to the 5th. Okay, and again. So this is 4 goes into 3 to the 4th power. So 4 goes into 4 once, so there's my 3. 4 goes into 8 2 times, so it's R squared. And 4 goes into 20 5 times, and there's my S to the 5th. The little shorter way of doing that. And you're fine doing that too, instead of writing all this out. But this is kind of like fun at first to kind of get the hang of what we're doing with this. Okay? Okay. All right, let's go on to another example. I hope you read my emails about what we're doing next week. And I can take a moment while I'm erasing and tell you that next week, our first week back after this coronavirus issue that's come up upon us. And Tuesday, you're going to log in at your normal class time. And whether it's 1 to 3 or 3 to 5, you're going to log in at that time and you're going to take the test 3 that we had scheduled to take in class. But now with this change of events, we're going to take that test online. That's all you got to do for Tuesday coming up. Right, each expression. Okay, here we go. So this is rational numbers. Here's rational numbers as exponents. Okay, so what are they talking about here? if I have a root here, and I'm just going to call it n. I'll get into some real problems because I like it better to learn when we're using real numbers. So if I said, what is the square root of x? Oh no, the nth root of x. If I did that, let's see then. So I could write this as a rational number as an exponent. And that, what does that mean? That means I'm going to have a fraction for an exponent. You know, like what? You know, something like x to the maybe 2 over 3. This is something we haven't seen yet. All right, we're going to learn about it now. Where does this come from? Okay, so if I have the nth root of x, then I could write this as x to the 1 over n in this case. And why is that? Because this x has an exponent of 1, really. So then when I write this out, I can say, oh, the n is the index number, and the 1 is what this x is raised to. Okay, and that's it. So if I'm looking at, well, I'll take this one. This is my examples here. What is this saying? This is saying, if I wrote this with the radical sign, okay, rational numbers as exponents. So I'm going backwards with this one, actually. All right, here I went forward. This is a rational number as exponents. So this is where it comes from, the nth root of x to the first, and I can write it with a rational number as the exponent this way. So it's 1 over n. So this one, if I go backwards, well, what's the index number come from with x to the 2/3? The index number is the denominator, and the denominator is 3. And this x squared is just going to be inside, like so. And that's how I do that conversion to writing from radical notation to exponential notation. Okay, let's see what else we have. Okay, what do we got? Write each expression as a root and then simplify if possible. Okay. Okay, yeah, so let's get rid of this here and go for it, Rocky. All right, how about 8 to the 1/3 and 36 to the 1/2, negative 25 to the 1/2. And then negative 25 in parentheses raised to the 1/2. And it looks like we got a fraction here, 4 over 9. And I don't know why I'm saying this out loud, raised to the 1 over 2. Okay, so let's roll here. All right, so I have to write this in radical notation. It says write expression as a root and then simplify. So I have to write it as a root. All right, I can do that because I know these are my root symbols here. So I can go ahead and just put them in here right now. See what I can come up with. All right, and so I'm writing them from rational exponents into root form. All right, so let's see. This denominator is telling me what the index number is, so that's 3. The 1 is the exponent of what lies inside here. So that's going to be 8 to the first power. So this 8 to the 1/3 means what's the cube root of 8? Okay, so that's kind of it there. You got to remember the most important is the denominator is the index number. Okay, so here I don't have to write the 2 because that means it's a square root. If you do write the 2, that's okay. But we're all online now on homework and exams, quiz, if we have quizzes, whatever. Okay, so this one's just going to be what? The square root of 36. This 36 is the radicand that stays underneath the radical sign. Okay, here I've got a negative. So let's see, this is going to be, negative is going to be on the outside here. And then what is my index number? It's 2, so it's a square root of negative square root of what? And then I'm going to take that 25 and put it here. And that's what this is saying. This negative square root of 25, what would be my answer here now? That would equal negative 5 for that one. Now notice here I have the use of parentheses. Now that's telling me that the base is negative 25. The index is 2, which means it's the square root of negative 25. Right? That's what this means when it's enclosed in parentheses. I've got to put that base underneath the radicand, as the radicand. Okay, and I know this is the square root because the denominator is 2. So this one does not exist. And finally, this is the square root, because the 2 is here, that's my index number. So it's saying, what's the square root of 4 over 9? And the square root of 4 over 9 is 2 over 3. Okay? That's what we're talking about here. Not bad. And remember, on our little new setup, you can, for the most part, send me text messages on that Remind app. That's what it's for. And especially now, we're kind of cooped up at home. So if you've got an issue, you can take a picture of it. Whatever your concern is with a problem, take a picture of it, and you can give me what you're doing. Don't just send it to me. Some students will just send me a problem and want me to answer it, and I'm sending it back. You got to tell me what the problem is, and I'll lead you on to the correct answer. Okay? So I want to hear from you, but I don't want to hear from you for every problem. I know that trick. Okay? All right. So let's get rid of this. And what's good about video, too, you can watch it a second time, a third time. You can skip around. And, you know, I know I've got this tape, I call it tape, this recording running continuously, so you got to see me erase the board and all that kind of stuff. And I'll try and shorten it up somehow if I can, without too much trouble. But there's something called editing, and, you know, this is new to me as it's new to you. And I'm going to do my best to make it convenient for you. But right now, maybe this week, you may have to skip around. And you can just, you know, bounce around on it using the arrows on the bottom, whatever it takes for you to skip around, get to the point. And that's my main focus there. Okay, remember properties of our exponents. So let's remember some of those. What is it? In our book, and you know, I should tell you what page I'm on, which is, well, I'm in 6.1, that section, page 513. But let me copy some of these down if I can see. R times a to the s equals a to the r s Okay, I guess we can start here. There's one more over here. I'll put a couple more here. A to the R over A to the S. And A to the 1 over R. Okay. Let's remind ourselves of the properties of exponents. That's what this is about. And the property when I'm multiplying bases that are the same with exponents that are different. So this is going to be a to the r times a to the s is going to be a to the what? R plus s, where we add the exponents. Okay, so if I had a to the 7th times a to the 3rd, my answer would be a to the 10th. I just add those up. Okay, this is the power rule, a to the r raised to the s, so I can multiply the r times s, and this would give me a to the r times s. Whatever those two numbers may be. ab raised to the r power, I could distribute. There's really a 1 here and a 1 here for the exponents in the parentheses, so I can distribute that r to each of the 1's in this case. That's what my exponents are, and this would become a to the r, b to the r. Remember our negative exponents? We want to turn it positive always, so this would be this would be 1 over a to the positive r. This is really a to the negative r over 1. So I want to bring it downstairs to turn that negative r exponent positive r. And then I have to have a 1 up top because this is going to the bottom, so I need something up top. So that something can only be a 1. Okay, this is a over b raised to the r, so I can rewrite this to be a to the r over b to the r. Okay, remember that one. And this is the quotient rule, the opposite of the multiplication property. So this is going to be a to the r minus s, or if I did it as 1 over a to the s minus r. I mean, sometimes I can subtract the top from the bottom, and whatever the case is. But what's the rule for that? Always subtract the smaller number from the larger, and you will probably end up with a positive number for your exponent, which is your main idea here of doing. And this one that we just did a moment ago, did several of these. This is going to be, let's say I got to write this in radical notation. So that means, what is my index number going to be? Correct, r. And then this is raised to the first power. So it's really right here, a to the first power, but I can just write it as a. Okay, and there's our review, a quick review of the properties of exponents. All right, very nice. Let's see where we're heading. Write each radical with rational exponent, then simplify. Okay, well, I think we kind of did some of these, and let's try it. All right. How about it? Well, here they are. So example 5, I've got the cube root of x to the 6th and y to the 12th. That's my first one. How many do I have here? 2? Yeah, there's 2 here. So I'll put them both here, side by side. And the next one, I have the 4th root of 81 r to the 8th s to the 20. My God, didn't I do this? Or is that similar to one I had earlier? 4th root of 81. That's crazy. I just did that one. RS. That's what I don't like. A to the 4th, B to the 8th. Okay. Well, never mind about that. All right. Well, I kind of did these already. So here, this is what's the cube root of x to the 6th and y to the 12th? I could expand that again and take for every 3, take 1 out. I'll leave that for you to do. And then in the meantime, since I kind of done it already, I'm just going to say, well, this is the index number, this is the exponent. 3 goes into 6 2 times, so this is x squared. And 3 goes into 12 4 times, and that would make it y to the 4th. And you get the same result. So that's the cube root of x to the 6th and y to the 12th. Okay, I guess so. All right, here's another one. We did this not too long ago. The 4th root of 81. Well, you know, if anything gives you a hard time, it would be that, maybe, the number under the radical. So that's going to be 9 times 9, which is going to be 3 times 3, and this 9 is 3 times 3. So there I have 4 3's, and that's the 4th root. So for every 4 of the same number, I'm going to take 1 out. So I got a 3 there, and then I can proceed by doing this. Instead of writing 8 r's out, and then take for every 4 of the same r, I'm going to take 1 out. 4 goes into 8 2 times, so that's r squared. And then 4 goes into 20 5 times, and that would make it s to the 5th power. And that's my answer for the 4th root of 81, r to the 8th, s to the 20. Okay, did I do that right? I did that right, and that's my answer. Good. Okay, let's see, rational exponent theorem. All right, more of the same is coming. So let's see, I've got some problems here. Let me write them up on the board. Let me erase this, but well, I can. Well, this may be painful doing this with the pausing and that, but no, we'll keep trying. That's my job over the weekend, to try and simplify this. Okay, so here's what we're dealing with now. I've got to write this in radical form, perhaps, and then I have to simplify them. 8 to the 2/3 power. So what does this mean? This means I'm going to have a radical with an index of 3. That's my denominator again. And then inside I'm going to have 8 squared. 8 squared is 64. So I could say, what's the cube root of 64? My denominator is the radical, and then this part here is what goes under the radical sign. Okay, so you don't get confused with that. This translates to be this, cube root of 64, and then I'm going to do the prime factorization of 64. So let's see, over here I've got 64, and that's 8 times 8. I know the 8 breaks down to be 2 times 2 times 2, and this 8 would break down to be 2 times 2 times 2. Okay, and then I'm saying, what is the cube root of this? And then I can say it is going to be for every 3 of the same number, I'm going to take 1 out. So here's 3 2's, a 2 comes out. Here's 3 more 2's, another 2 comes out. So I've got 2 to the 2, which is 4. So this ends up equaling 4. And we're done with that. Okay, you could have taken it from here and gotten it, because you know that the 3rd root of 8 is 2. And so we got, here's an 8, so that would be a 2 comes out. And here's an 8, a 2 comes out. There's your 2 times 2 is 4. But remember, I'm breaking it down so everybody will be successful. Everybody. Okay, number whatever number this is. I'm going to convert this to a radical expression. So that means I'm going to have the square root. That's a 2 there. If you want to write the 2, by all means, go ahead. It means the square root. And this is going to be 25 to the third power. Okay, so that means what? I'm going to have what? The square root of 25 to the third power. So that means I'm going to have 25 times 25 times 25. I think I could do it that way. And then what else have we got? 2 of the same number, perhaps. So this one I could keep going and break down these 25s. And that would be 5 times 5 times 5 times 5 times 5 times 5. Let's see how I did with that. 25, 25, 25. And now I'm taking the square root again of these numbers. So what can I do? I can, for every 2 of the same number, I'm taking 1 out. So here I've got 5 times 5, so a 5 comes out. Here's 2 5s here, a 5 comes out. And 2 5s here come out. So it's 5 times 5 times 5. This ends up equaling 125, which would be 125, like so. Okay. And finally, oh, we got a couple other ones here. So let's see. Oh. Okay, how about that one? So take a look at that one. You know, these can be done somewhat differently depending on how good you are with your times tables, manually without a calculator, etc., etc. Because why? Let's say on this one. If I went back to this one, an alternative way of doing this would be, let me get rid of this. And you'll discover this as you're doing them as well. You could say, well, what's the square root of 25? I'm going to go about it a different way. The square root of 25 is 5 raised to the third power. So this would equal 5 to the third power, which also equals 125. I'm taking the square root of this 25, which is 5, and then raising it to the third power. So that's another way of doing the same type of problem. Okay, how about this one here? Now I got that negative square root. So let's see. Well, I want to make this positive here. This may cause me a little confusion. Okay, so I could rewrite this to be 1 over 9 to the 3 over 2. Okay, following our properties of exponents, so I know I can do that. And then I can rewrite this to be 1 over the square root. My denominator is the index number. And then this is going to be 9 to the third power. Okay, so there you go. So I'm going to have to evaluate this. So I'm going to do this one like I did the alternative way here. So that's going to end up being 1 over, what's the square root of 9? The square root of 9 is 3, and 3 to the third power is 3 times 3 times 3, which is 27. And this is my answer for that problem. That's a lot easier than breaking it down to be 9 times 9 times 9, and then taking each 9 and breaking that down, and then taking for every 2 of the same number, etc. So this is feels like it's a little easier. Okay, and then finally we have this. So this is the basically the same thing, I think. And let's try. So I'm going to have, let's see, this is negative here. So wow, I'm going to put this as 1 over, and then I've got 27 over 8. And now that's going to be the 4th root over 3. Rewriting it as a positive exponent. Okay? And then I can split this up to be, so this will equal 1 over, and for the 27, I could write that up as the cube root of 27 to the 4th power. and that would be over the third root. My denominator is my index of 8 to the fourth power. Okay, good enough. So now I'm going to have 1 over, let's see, I've got the cube root of 27. The cube root of 27 is 3. And 3 to the fourth power is 81. 3 to the fourth power, 81. 3 times 3 times 3 times 3. But 9 times 9, 81. Okay, and then I've got this on the bottom to say, what's this going to be? The cube root of 8 is 2, and 2 to the fourth is 16. So I got this as 1 over 81 divided by 16, which is going to end up being, I'm going to flip that, right? Keep, change, flip. Keep, change, and then flip. 16 over 81. 16 over 81. And I can't simplify that at all, so I'm going to leave that. And that was this one here, okay? All right, so that is our first. I got one more set of examples to do, and then we'll be done. All right, so grasp that, and again, you can ask me questions during the meantime of watching this video up until Thursday of next week. That's March 26th, I believe. Okay, hold on. All right, so here we go with example 7, and we're now going to use our properties of exponents with rational exponents. All right, so this is a matter of dealing with fractions again, and I think we were getting pretty darn good with fractions, even doing it manually, I hope. All right, so here's our first one. So this is the property that's called the product rule. I want to use the product rule where my bases are the same, so I can add the two fractions. So this is going to be x to the 1/3 plus 5 over 6. Okay, and then so let's go, what is 1/3 plus 5 over 6? And we're back to get the denominators the same, which you've all become pretty good at, which I'm really happy about. Totally happy about. All right, so here's my exponents. And so let's see, my denominator, numerator, multiply it 2 over 2. So I know I'm going to have a 6 here. And I'll add my numerators. 2 times 1 is 2 plus 5 gives me 7 over 6. Okay, and we're done. Oh, wait a minute. No, this equals x to the 7 over 6. Now I'm done. Okay, here is a power raised to a power, so it's going to be the power rule, so I'm going to multiply those two. So that means I'm going to multiply 2/3 times 3/4. Okay, remember these are just my exponents, so this is going to end up being, well, my 3's cancel. 2 over 4 is going to be 1 over 2, 1/2. So this is going to end up being y to the 1/2. And are we supposed to leave it in that form? Let me check. B1, yeah, so we're good with that. You get confused as to what they want us to do. So stop a moment, check the book, check whatever you're working on, and it should tell you what you need to do. All right, and then we've got C here. This is the quotient rule. So I'm going to subtract the smaller number from the larger one. Okay, and if you don't know with fractions, take either one. If it's a negative, then you got to change it to positive. Okay, so that means, let's see, if I did 1/3 minus 1/4, I can go ahead and do that. I know it's going to be z to something, so it's going to be what's 1/3 minus 1/4. Okay, so let's see, I'll get these denominators to be the same, so I'll multiply this 3 by 4, top and bottom, And this 4 I'll multiply by 3, top and bottom. And so I'm going to end up with a denominator of 12. And then a numerator is going to be 4 minus 1 times 3 is 3. 4 minus 3 is 1. So this ends up being 1 over 12, which ends up being z raised to the 1 over 12. And that's my solution for C. Okay, so that's using the properties of exponents, and nothing really new. I mean, we've done this already, but now we're going to be using them with fractions and adding, subtracting, multiplying, and there you go. Okay, so I've got 2 more examples and we'll be done. Okay, here's the last 2, and I turned the lights on down here because it was dark. I'm having a hard time seeing. So the glare from these lights flash onto the board, so it looks like this may be, I hope not, but you can let me know. So here's our problem, and hold on a moment. I want you to be able to see that. Yeah, that's a little better. Got a little, like a flying saucer there. All right, so here's my problem. And what do I want to do with this? This is a power rule I can use. So this is an A and a B, so those are 2 different bases, so I can't do what's inside the parentheses first. So I'm going to distribute that 6 to each of the exponents. So I'm going to end up with A to the negative 6 over 3, which is going to equal A to the negative 2. 6 divided by 3, negative 6 divided by 3 is negative 2. And then the denominator is B to the 1/2. Okay, and then that's going to be 6 times 1/2. And that's going to be 6 over 2, which is going to equal B to the 3rd. 6 divided by 2 is 3. Okay, and this is where I'm at thus far. And the only thing to do is change that negative exponent positive. So this A to the negative 2's got to come downstairs. And I've got to make sure something is in the numerator, which is going to be 1. And I'm going to end up with 1 over A to the positive 2, B to the positive 3. So there's my answer for that one. Okay. And the same thing, similar going on here. Well, I'm checking it out here. Let's clean up the numerator by distributing that exponent of 4 across. So that's going to be what? X to the negative 12, y to the 4 over 2. Okay, and that's going to be x to the 10th, y to the 3 over 2. Okay, good with that. And what shall we do next? Let's simplify these. So what I like doing is taking that negative exponent, just bringing it downstairs, and I can park it next to the x to the 10. So I can take this and bring it down here and just make the exponent positive. So that's x to the 12. This is gone now. I'll put a 1 here. And then I've got looks like I'm going to have the, what's it called? The quotient rule. Y to the 4/2, which is really 2, and divided by y to the 3/2. So I'm going to say what's 4/2 minus 3/2. Let's see if we do it that way. So when I do that, it's going to end up being y. What's 4/2 minus 3/2? The denominators are the same. So I'm going to have 2, 4 minus 3 is 1. Y to the 1/2. And where am I doing that? In the numerator, right? I brought this up. I'm doing it in the numerator, so that stays in the numerator. And then what's the denominator going to be? This I already brought up, so this is gone. Then I have x to the 12th times x to the 10th, which is x to the 22. And that looks like it for that problem. Yeah. Okay, so that's what it is for this lesson. 6.1. This is what we did today. This is our first video, my first video, our first video. And so what you're going to do is take this, and on Thursday, when you log in, you're going to do your homework for 6.1. That's all there is to it. Each section, one day, each section. And then on a Tuesday and a Thursday, when you log in from home, I'm taking attendance there too as well. You have to get that done during class time. So you got 2 hours to do, I think it's 25 problems for this section. Okay, I know we can do it. We can do it. And I'm here to help you too. Don't forget that. Like I say, I'm stuck at home. My wife's stuck at home. So it'll be a nice way to, give me something to do around here. But don't drive me crazy either with questions that are simple. I mean, give me a question that you're really struggling with. So do your best to get this done. And I know we will get through this semester. What do we got? Like 7 weeks of this to go? Wow. Never happened to me before. Never happened to anybody. Okay, so that's it. And that's what the plan for. Remember, next week, Tuesday, you're going to log in, take the test, you're done. Take your time with the test. I hope you're getting that homework done. Everything counts still like we do. We're going to follow the syllabus the way I had it laid out. And we're going to stay with that, doing it this way. And, I'd much rather be in the classroom talking to you individually, as a group. It was getting kind of fun. But, since this has happened this way, we still can communicate with each other. But we'll have to do it at the times of the class when we're in, I don't want to say in class, but when we're online doing the homework on Tuesday and Thursday. I'm going to be online too to take your questions as you're doing the problems. And whatever I was saying, I forgot. So goodbye until next time.